This is the first example that you're going to use for your test tomorrow. We're going to calculate the minimum area of each member of this little bitty triangle truss, or if it is made out of Douglas fir, so it's made out of wood. So the first thing we have to do for every one of these problems is draw a free body diagram. So there's a roller at A. I need to replace it with its force at A. And since it's in the x direction, I'm going to call it FAX. There's a pin at B. I'm going to replace it with the force. So I've got FBX, but I also have FBY. Okay, so now that I've got the problem set up, I can go into equilibrium equations. So I start out with sum of the forces, and the x direction needs to equal 0. So I got to look at everything in the x direction. I've got FBX. It's moving to the left, so that's a negative FBX. I got FAX moving to the right, so that's plus FAX. And I've got 6,000 moving to the left, so that's minus 6,000. All of that equals 0. Right now I've got two variables in the x direction, so I can't go ahead and solve for either one of them right now. I've got to move on to another equation. The next equation I usually go to is sum of the forces in the y direction equals 0. And I've only got two forces in the y direction. I've got FBY going up, so it's positive, and I've got 3,000 going down. That equals 0, which tells me that FBY is equal to 3,000 pounds, and that's an answer. All right, I still have two unknowns. I don't have any extra equations that have them in them, so I've got to go on to my next equation, which is going to be sum of the moments. And I'll do sum of the moments at A this time. They need to equal 0. So if I'm looking at A, forces that are going to make a moment can't pass through A. So if this 6,000, if I extend the line of action, goes right through A. That one's not going to make a moment. FBY, if you extend its line of action, it goes right through A. It doesn't make a moment. FAX goes right through A, so it doesn't make a moment. Okay? So the things that are going to make a moment are going to be FBX and the 3,000 pounds going down. So I have to look at this FBX. It's an X force, so I need the Y distance between it, and it's going to cause a counterclockwise moment. So that's going to be 4FBX. And since it's counterclockwise, it's going to be positive. The other one is this 3,000. It's a Y force, so I need the X distance away, which is also 4. And it's going to cause this to go clockwise. So it's going to be negative. So it's minus 4 times 3,000 equals 0. Doing a little bit of algebra, FBX is equal to 3,000 pounds. I'm going to plug that back into my sum of the forces in the x equation. I'll get negative 3,000 plus FAX minus 6,000 equals 0. So that means I'll get FAX is equal to 9,000 pounds. All right. So I've got my external forces. Now I can solve for my internal forces. So I'm going to start at joint A. And in joint A, I'm going to redraw what I have. I'm going to draw AB in tension. It's moving away from the joint. I'm going to draw FAX, and I said it was 9,000 pounds. And then I've got AC. I'm going to draw it in compression going towards the joint. So I'm going to start with some of the forces in the X direction equals 0. I've got 9,000 going to the right, minus AC, because it's moving to the left, equals 0. And so I'll get AC is equal to 9,000 pounds. Some of the forces in the Y direction equals 0. I'll get AB, and that's it. So it equals 0. All right, the next joint I'm going to go for is joint B. You can choose joint C or you can choose joint B. I'm just going to choose to do joint B this time. So I need to redraw what I've got for joint B. So joint B had FBX. It was going that way. And I already know what FBX is, so I'm going to go ahead and put its number on there instead. FBX had a value of 3,000. And then I've got FBY, which had a value of 3,000. I have FAB, but I know that that one's 0. And then I've got BC. Okay. So I'm going to go ahead and do some of the forces in the X direction. They need to equal 0. I've got 3,000 going to the left, so minus 3,000. And I've got BC going to the right, so plus BC. But it's only the part of BC that's in the X direction. Now, this is an equilateral right triangle, so that means the interior angles are 45, 45, and 90. So to get the X part, I'm going to do BC cosine 45 equals 0. So I'll get BC cosine 45 equals 3,000. Divide everything by cosine of 45 degrees. And what do I get? All right, so when I divided 3,000 by cosine 45, I get BC is equal to 4,242 pounds. Now, I drew it in tension. I got a positive number. That means this also has to be in tension. I go back, make sure I labeled the other one as compression. AC, I drew in compression. It was compression. Got a positive number. Now, I got to use the things that I was given. I started out with a sigma tension is 8,100. PSI. And sigma compression is 7,400 PSI. All right. Sigma is equal to force divided by area. So I'm going to start with BC just because it's on the board right now. So I've got 7,400 because it's in compression is equal to the force at BC, which is 4,242, divided by the area of BC. So I put in my calculator 4,242 divided by 7,400, and I should get that area of BC is equal to 0.57 inches squared. Okay. The next one is going to be 8,100 PSI is equal to force AC divided by area of AC. And I already know what the force in AC is, so I'm going to actually rewrite that. The force in AC we calculated was 9,000. So on my calculator, I put 9,000 divided by 8,100. I get A of AC is equal to 1.11 inches squared. An area always has to be in a squared unit. And that's how you solve that problem.